Greetings to Madam Shuhada. I'm Khalilsi Mohan from DCE2A. My matrix number is 33DCE20F2016. Today I would like to present my practical task 3 for material science and engineering. The title of this practical task is Izod impact test. The objective of this practical task is to find the impact resistance of mild steel and cast iron. The apparatus used in this experiment is impact testing machine. What is Izod impact test? Izod impact test signifies the toughness of material, that is the ability of material to absorb energy during plastic deformation. Toughness takes into account both the strength and ductility of the material. Step 1. Select the Izod test specimen which are given cast iron and mild steel. For the first experiment, I will choose the cast iron. The length of the cast iron is 75 mm. The breadth will be 9.3 mm. The depth of the cast iron is 9.4 mm and the depth of notch of the cast iron is 4.2 mm. Step 2. Test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. The loss of energy due to the friction is 2 joule. Step 3. The Izod test specimen as per Indian Standard IS 3766-1977 is placed in position. Step 4. The pendulum is released. The hammer strikes against the specimen, breaks it and swings further than the observation is noted down. In this experiment, we have to conduct the experiment 3 times. The total loss of energy during transit of hammer is 5 joule and the energy for failure for specimen will be 3 joule. The observation of the first trial is the initial energy of the hammer will be 164 joule. Average loss of energy due to friction is 2 joule. Total loss of energy during transit of hammer will be 5 joule and the energy for failure of specimen will be 3 joule. We will conduct the experiment for the second time. The pendulum is released, the hammer strikes again the specimen, breaks it and swings further than the observation is noted down. The total loss of energy during transit of hammer will be 6 joule. The energy for failure of specimen will be 4 joule for the second trial. And this will be the observation for the second trial. The energy for failure of specimen will be 4 joule. For the third trial, we have to repeat the step 4. For the third trial, the total loss of energy during transit of hammer will be 8 joule and the energy for failure of specimen will be 6 joule. This will be the observation for the 3 trial by using the cast iron. The average energy for failure of specimen of cast iron will be 4.33 joule. Now we will repeat the experiment by using mild steel specimen. The length of the mild steel is 75.7 mm. The breadth will be 9.54 mm. The depth of the mild steel will be 9.6 mm. We have to repeat the step 2 by using the mild steel. The joule will be same, 164 joules. Then the pendulum have to be released. So the loss of energy due to the friction for the mild steel will be 4 joule. Now will be the first trial using mild steel specimen. Repeat the step 4. The test piece was not broken by striking energy of the testing machine, so the impact value obtained is indefinite. This will be the observation for the first trial using mild steel. Now for the second trial using the mild steel. The total loss of energy during transit of hammer will be 56 joule and the energy for failure of specimen will be 52 joule. This will be the observation for the second trial by using the mild steel. Now this will be the last trial for the mild steel. So the total loss of energy during transit of hammer will be 46 joule and energy for failure of specimen will be 42 joule. This will be the observation of the 3 trials using the mild steel. The average energy for failure of specimen for the mild steel is 47 joule. In the end of the experiment, we can conclude that mild steel is more impact resistant than cast iron. This is because steel is excellent at withstanding sudden impact without bending, deforming, or breaking. This is due to the toughness of the material. That's all from me. Thank you.